Hello, this is Professor Needham. We are going to use Desmos in order to calculate a single mean confidence interval level along with a test statistic, and we'll make a p-value determination. We're going to be using the two formulas from our formula sheet for both a confidence interval level and for a t-test. A t-test is super similar to a z-score. The only difference is that a t-test is distributed on a t-distribution versus a z-distribution. A t-distribution is slightly different, as we've seen in the past. It's slightly narrower and slightly higher than the t-value. Let's look at a question. A car company claims that their super spiffy sedan averages 31 miles per gallon. You randomly select 8 super spiffies from the local dealership, and you test their gas mileage under the similar conditions. Here are the scores that you get. Does the actual gas mileage of these cars deviate significantly? It doesn't say, is this average less or greater? It says, does it deviate, meaning, is it higher or is it lower? The goal of your analysis is to test a significant difference between the sample mean, which we don't quite yet have, and the proposed population mean. We will test the mean of these data values against a 331, and again, we'll use an alpha level of 0.05. We're performing a one sample t-test of this data. So the first thing we're going to need, if we look back at our formula, is we're going to need two things. We're going to need a sample mean, x bar, and we're going to need a standard deviation, s. So we're going to go to the calculator of Desmos, and we're going to find these values. So the first thing that I do when I go to Desmos is I put in all of the values into a list. So take the time right now and put them into a list. Make sure that you give it some kind of letter. It doesn't have to be A. And make sure you use an equal sign. Once you create those values, now we need to actually do a couple calculations using Desmos. And you certainly could use a different calculator if you like, but Desmos is pretty quick. First thing we're going to do is calculate the mean. Now, I'm going to type the functions, but yet at the same time know that all the functions are available down here in stats. If you're looking for a mean, it's right here. So you could either click it and it'll do it for you, or you could remember that it's the mean value. You have to put in the list A, and you can see that we have a mean of 29. I need a standard deviation, STD, DEV, parenthesis A, or again, go down to the function list. I need that standard deviation. And we'll use 2.78. So let's write down a couple of things that we currently have. We know that we have an x bar of 29. We know that we have a standard deviation rounded to 2.78. We're going to calculate a t-score. So our t-score is going to be x bar minus mu divided by standard deviation divided by the root of n. Go to your calculator, and I'm going to say we're going to round to 2 places here. We're going to have a negative 2.03. You can use either Desmos or a standard scientific calculator to get those values. Now we have to calculate the p-value for this, because we need to know if we have significance here. Now remember what we just found is that on a t-distribution with 0 at the center, we're at approximately negative 2.03. We're testing to the left. Why are we testing to the left? Because it's a negative number. If we had got a positive, we would have tested to the right. Because remember, it's the score, or more extreme than the score, from 0. We need to calculate for here a p-value. Now remember though, we have to do this on not a normal CDF, but we need to do this on a t-distribution, because a t-distribution is slightly different. So we again go back to Desmos, and now we're going to do a distribution. Well, let's go down to the function table. Let's look at distribution, D-I-S-T. Not a normal distribution, but a t-distribution. It asks you for the degrees of freedom. There were 8 elements, so we have a 7 degree of freedom. I'm going to ask to see its cumulative probability, that's CDF, its area. When it does that, it asks me, where would you like to place these things? Okay, well, it's a left tail for me because remember, I have a negative number, so my minimum is negative infinity, but my maximum is going to be the negative 2.03. And I wind up with this nice little probability right here that shows 0.04. 0.04 is the p-value on one tail of my test. Now remember what our question was. Our question was, does it differ? Is it not the same? So when I test this p-value, I'm going to change color. On this one-sided p-value, it's 0.04. But remember, there's a whole nother 0.04 if we had deviated to the right-hand side. This does not ask less, it does not ask more, so therefore our p-value is a double indication, or gets multiplied by 2 to achieve 0.08. Looking back at our alpha level of 0.05, we are greater than that alpha level of 0.05, so therefore we fail to reject. Now, if the question had been stated a little bit differently, and we had just been talking about things less than the particular 31, then that would have been the reasoning. Now, let's see why maybe that takes place. Let's go and let's do a calculation for the actual confidence interval level. So we're going to need X bar, which we have. We're going to need T star, and I'll show you where to get T star real fast. We're going to need the standard deviation, which we have. We're going to need N, again, which we have. So one of the things that we don't calculate a lot of is inverse T or T-scores. And I just use a calculator generally to come up with my T-score values. If you go to ttable.org, again, ttable.org, there's a nice little calculator right here that says, what are your degrees of freedom? 7. What is your significance level? Let's test at let's go with 95%. Or actually, let's go with 99%. Let's put in 0.99. That's my area of my significance level, and all the directions are right here on the top. Just simply hit calculate, and here goes your one-tail or your two-tail values right here. So from here, you could certainly calculate using. Let's just go ahead and calculate for one tail. Let's use the -3. It was a two-tail test, but let's do the CI here. And let's say, what's a CI for a one-sided value? So let's go here. So we're mixing it up a little bit, but that's okay. Let me give myself a little bit more room here. Let's do we're going to do a CI for a one tail. So the first thing I have to start with my CI is my mean value. That was the mean, the X bar value that I had. I'm testing for the X bar. If you go back to, I'll show you where we're at. Go back to here. Remember, it's based on not the mu mean, but it's based on the sample mean. So I have that 29 in for that sample mean. I'm adding, subtracting that one tail z-score, which was, or t-test, which was 3. It's going to multiply itself by 2.78, which was the standard deviation, divided by the root of n, which was 8. Remember, not the degrees of freedom, but the sample itself. Do the -1 first and get approximately 26.05. Do the +1 next and get 31.95. Now, what does that tell me? That tells me that the range of scores, 95% confident, would be anywhere between 26.05 and 31.95. Remember that our original score that we had was 29. It fell within inside of there, so we would fail to reject. It's perfectly acceptable for 29 to be in between 26.05 and 31.95 on a 95% CI. Hope this helps you out. Enjoy, and check back later for more videos.